I hope you're all having a great evening. I am Mr. Ish. Thank you for joining me. In this video, I want to do this single exercise where we have to verify an inverse trigonometric expression, focusing here on the arc tangent. The expression is this: arctan x plus arctan 1 over x is equal to pi over 2. You have to verify this identity to be true. A good way to proceed over here for this specific expression is to separate it into two parts, with each part equaling into its own independent function. If this right here represents y is equal to arc tan x, then that right there would equal, with this item going here on the other side, would be y is equal to pi over 2 minus arc tangent 1 over x. And remember, in all instances, the verification procedures should be relatively simple and they should be efficient. You should try to get to or through your procedures in a quicker manner than something which is more long and more drawn out. When you're looking here at y is equal to arctan x, focusing right over here, you can take the arctan or the inverse tan on the other side. You'll have x is equal to tan of y. Coming right here from the first expression, we'll call that a. When we're looking here at b, what can you do over here? Take the pi over 2 on the other side. You have y minus pi over 2 is equal to minus arctan 1 over x. Now you can take the minus on the other side. You'll have things flip around. You'll have pi over 2 minus y is equal to arctan 1 over x. Now the best item here as we continue with this is to take the inverse tan on the other side. You're looking at tan of pi over 2 minus y is equal to 1 over x. There are two things which have to be done over here. You're looking at something for which a co-function identity can be brought in, and you're looking at something for which something can be substituted right here. If you're seeing x is equal to that, you can do a substitution right over here, and we can continue with everything right over here. If you think about the co-function identities, you know tan of a 90 minus angle is always equal to cotan of the complement. You also know cotangent of any angle in terms of a complementary is equal to the tan of its complement. You know that. These are proven, verified trigonometric identities. You have something right over here which looks like something right here, and that right here would equal to cotan of y. Everything here with regards to the y variable. Tan 90 minus y would equal to cotan y by means of the co-function identity is equal to 1 over x. But I also know x is equal to tan y. I can do that substitution right over here is equal to 1 over tan y. When you look at this, you know very well that this right here is your inverse trigonometric expression verified and proven to be true, because cotan y would definitely be 1 over tan y, because if you were to bring in the expression for tan y, you're looking at a sine y divided by cosine y. If you were to flip this around, you're looking at a cosine y divided by sine y, which indeed would be a cotangent y. So that right there is equal to exactly what you see over here. In terms of the y, the identity is proven to be true. So that right there is the end of this verification procedure. Again, you started by splitting your expression into two parts, each equaling an independent function. You start off here with the very first one. With the second one, you manipulate it such that you arrive at this point over here. You bring in the co-function identity, you bring in the substitution here from the very beginning from part A, and then you do a verification here with regards to them, both of these being reciprocals of one another, and that takes you to your completion. And that's about the end of this verification, about all that I wanted to show you in this video. If you have any questions or comments, feel free to leave them for me. Thank you. Have a great day.